Welcome back to our weekly Gruber Power Services podcast. I'm Pete Gruber,
I'm Claude Dixon. Good morning, everybody.
and we are here today to entertain you, answer questions. And the background, by the way, is an AI generated image of a data center. We've been trying to select images that are consistent with the theme. And any of you that have questions, feel free to ask them. Let us know where you're coming in from, what country. The platform is visible to us, so we can see that. And we're available to answer the questions as they come in. So anyway, I'll turn it over to Claude at this point.
Yeah, so I have a question for you all out there. Are you prepared? Are you prepared? Because we are in storm season. We're getting ready to hit storm season here, and having your mission critical infrastructure ready to go prior to that is absolutely critical. So, monsoon season for those folks here in Arizona, actually, monsoons happen all over the world, but for purposes of where we are, the season is June 15th through September 15th. So if you're here in Arizona, you still have time to ask questions and get yourself ready. We'll go into that a little bit later on how you go about doing that. Then, of course, hurricane season, right, Pete?
Absolutely, yeah.
Yeah. Hurricane season runs from June 1st to November 30th, a little bit longer. It actually has already started. And then, of course, tornadoes. Believe it or not, we've had 649 tornadoes so far this year in the United States.
Wow, wow.
That's
And
incredible.
the whole purpose of people getting critical power equipment, uninterruptible power systems, is to prevent the downtime that occurs from these kind of weather anomalies. Now, during the rest of the year, you're going to see an occasional power outage, but it's definitely elevated risk during these kind of weather anomalies.
Right. And for those of you on the outside that don't, know exactly what a monsoon is, I mean, it packs a punch. It packs wind. It packs dust. There are lightning strikes. Believe it or not, a lightning strike could happen a half mile away from where your building is, and you could still suffer a power outage as a result. 20,000 volts in a lightning strike. And 600, another number that's amazing to me is in Phoenix alone, over the course of the year, there's 600,000 lightning strikes.
Really?
Yeah,
Wow.
in the city of Phoenix, just the metropolitan area and all that surrounding area. I
Hmm.
thought that was absolutely amazing. And of course, when it comes to critical power, when that happens, it causes the surges and the sags and all those things associated with it.
Sure, and what lightning is trying to do is create a path to ground to get rid of the charge, basically, and it typically tries to hit the highest object that it can find, the path of least resistance, which oftentimes are high tension power lines, anything that sticks up in the air, tall trees, for example. And when it hits something that is related to the power grid, you suddenly have this massive surge of energy that then triggers a bunch of safety devices. Circuit breakers open up, and what you have is a power outage until the utility can reset those protection devices.
Yeah. So before we get into the four keys, I kind of put it that way, the four keys of protection, I wanted to show you some images. So Jesse, if you could put up a couple of the storm images, what these things look like. And unlike my counterpart over here, Pete, these are not AI generated images. These are actually
Number
images
one.
I took with my cell phone, believe it or not. So I want to show you a couple of these. Okay, look at that. That's a beautiful pathway, but if you look in the backdrop, that is a real storm. This happens to be in Arizona, northern Arizona, the Horseshoe Bend Trail. Horseshoe Bend is part of the Grand Canyon, and you can hike down about a mile and a half and you see this fabulous picture. I'll show you that in a second, but the main point here is what you're walking into.
Hmm.
Unfortunately, on this day, I had to abort this trail. I could not finish it because of what you don't hear. When you're actually out there, you can hear the thunder claps, the wind was blowing, and I had to abort this trail for safety reasons. So, this is an example of a storm.
So did you see lightning in that dark area there
Yes,
as well?
in that
Okay.
darkness. Now, keep that visual image in your mind, and let's switch to the next storm, number two.
Now, number two is Horseshoe Falls, Jesse. You're
Yeah,
actually wanting number five, image number five.
That's it. Exactly. I don't know if you guys heard that. He said, this one doesn't look like a storm.
He thought he
Okay,
had the wrong image, right?
exactly.
Yeah, that's
But
weird.
you know what? This storm right here was frightful. This is the Petrified National Park. It is
Uh-huh.
the Clam Basin Trail. By the way, you can hike out. I was 2 miles in. You can hike out there and see prehistoric clams that are 200 million years old. Okay,
Wow.
that was the whole reasoning behind it. But when I came around the bend, I saw this. The wind was blowing, and believe it or not, in that cloud there was lightning in that cloud. Okay, 2
Amazing.
miles in, I had to abort this trail and come back and do it 2 weeks later because of what I faced. So these images are, and this is Arizona, these images are examples of the storms that we see here in the summer in Arizona, and they are lethal and dangerous.
Amazing.
Yeah. So let's go to the cave. This is what we're trying to prevent.
Image number 3, Jesse.
Look at this. Look at this. Believe it or not, this is an actual image of a cave located in Flagstaff, Arizona. It's about a mile deep. I went into this cave with my cell phone and thought the flashlight on my cell phone would light it up, but it didn't. I was stumbling all over the place. And thank God these people showed up with these lanterns, okay, and illuminated the pathway for me. My point is here is that you don't want to be caught in the dark in the middle of a storm where your power goes out, okay, because it's very, very creepy. Of course, you know, the data loss associated with that can be tremendous. The revenue that's lost can be tremendous. But this is exactly the scenario you don't want to see where your emergency lighting comes on.
Mm-hmm.
So, Claude, you were in this cave by yourself with a cell phone light?
Yes, it's about a mile long end to end. You enter. In fact, it's just a hole in the ground. You could walk right past it. You enter, and then all of a sudden it opens up, and it's a mile long. It's called the lava cave, and you walk all the way to the other side and back. And fortunately, these people were coming the other way, and I was able to see the pathway there.
And they had hat-mounted
Yes. I
was gonna
type
say, we need to get
illumination
you one of those
device.
coal miner lights.
But it gets back to my original point about being prepared.
Yeah.
Okay, I was not prepared to do this trail. I thought I was, and I thought I had the capability with my cell phone, but obviously that wasn't true.
Mm-hmm.
Okay. So here's preparation. This last image I'm going to show you. This is what preparation is all about. One thing right here though before I go on. Gruber services a lot of what I call prehistoric old equipment. Okay? It's the niche that we're in, and I classify this equipment as a hippopotamus. Okay? That's not going to be the image that you see. The image that you're going to see is the equipment that they're coming out with now. Can you show me that image?
Number 4, Jesse.
Look at this thing. I mean, look at that package.
Mm-hmm.
Study that picture. When you think of efficiency, this animal, this land mammal right here is the fastest one out there. This thing runs at a clip of 75 miles an hour. And
Speeding.
yes, and it's as fast as the acceleration on a 100. What's that Tesla, Pete? The 100?
Oh, the P100.
The P100. This thing goes 0 to 60 in 2.5 seconds.
Really?
This cheetah.
Amazing.
Okay, but I want you to study this cheetah because look at the eyes. When you talk about wind resistance, you don't see any ears. All 4 feet are off the ground. There's no tell this thing is efficient. Okay, so let's go back to the hippopotamus and the prehistoric UPSs. Okay, when you think of power efficiency, they're not very efficient, these old UPSs. The new ones, though, are more like this guy right here.
In the 90% range versus the older SCR-based UPSs around 70% or so.
That's correct. That's correct.
And you know, the downside of having an inefficient UPS is you're going to spend a whole lot more for electricity because that 30% delta ends up as heat
Yeah.
and inefficiency, stuff you can't use to keep things running. And it adds a second burden in that you now have all this heat you have to get rid of, so your AC systems are working even harder to try to handle that inefficiency.
That's correct. That's correct. So that's a cool image. I got a trivia question, though, for the audience. What do you think the number 2 fastest land mammal is? Anybody want to guess, Pete?
Rabbit?
No.
You guys have an idea?
I can't cheat because I was talking to Claude about it yesterday.
He already knows. Okay. I have no idea.
Bigfoot.
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 The mythical Bigfoot?
That's right. Bigfoot runs at about 56 miles an hour. I'm just teasing you. I do have a story. I did have an encounter as a fourth grader with Bigfoot, but that's not the land mammal. It actually is the ostrich.
The ostrich.
Yeah, the
Yeah,
ostrich.
that's true.
Yeah, runs at a 56 mile an hour clip. Yeah. And just one other thing before we move on, the fastest animal out there is the falcon. It flies at a clip of 240 miles per hour.
Oh, man. That's, all
That's
right.
fast.
Yeah.
That is fast. That is absolutely fast. Okay. So just moving on here, being in the position I'm in, and running service for 14 years, I get a lot of bad news, unfortunately, in terms of UPSs going down in the field for various reasons. And Pete really doesn't hear a lot about this because we tend to manage it, but there are times when he does. But, through that bad news, there are a lot of learning opportunities in how to prevent things from happening again. The same type of phenomena. There's different experiences, unique situations that come up. Each scenario is never the same because our company operates in a mixed vendor environment. We service all different types of UPSs, both component and modular. So each scenario is different. The size of the UPS is different. How it's wired is different. All those types of things.
A lot of variations, yes.
Yes. So what we tend to do, and it takes time to do this, is we get to the root cause. And what I have found is that when you identify the root cause, it's never what everyone said it was in the beginning, because there's a lot of emotion involved in a facility when your critical power goes down because your servers are down, you're not making money, et cetera, et cetera.
Mm-hmm.
Yeah.
Okay. So one of the themes, of course, today is the weather-induced type outages with equipment. And not only does that typically cause outages, but it can also damage the equipment.
That's correct.
Things like lightning, for example, traveling down the grid and hitting a UPS, which is designed to keep the power up and running, it can often knock it, just knock it down. Time for a story here. I
Sure.
can talk about Phoenix newspapers. Years ago, Phoenix newspapers here called us out and they said, we're down completely. Our UPS isn't even in bypass. It was a GE UPS, a large, 600 kVA. We got out there and we looked inside that inverter section, and there was plasma arc flash, which essentially is like metal evaporating, things that were melted basically. And it was pretty clear to us that this was a external induced lightning strike. So I remember, talking to the customer about this, and he theorized, is it possible this was a plasma arc that was developed because the inverter failed? And from what we've seen, it was pretty clear to us that this was an externally induced lightning strike that happened to migrate through into that UPS. Now, usually what you look for here is other indications of failures, because it doesn't just hit the UPS typically. It can hit many other things, on that circuit. This one was odd because it was confined to the UPS. So to make a long story short, we ended up, we fix a lot of things and we can rebuild a lot of things, but this one was smoked pretty badly.
Mm-hmm.
So we ended up replacing that entire 600 kVA GE UPS in that case.
Yeah, that UPS I remember cost like $60,000 to replace.
Exactly,
Yeah.
yes. And then, of course, you run into problems oftentimes is, can we get it quickly enough? Is there
Right.
one available? Well, you run into that
Yeah,
all
exactly.
the
The lead
Yeah.
time is a huge thing, and
Yeah.
that's a great segue because what we want to discuss next with you are the 4 keys from our viewpoint of protection, and a couple of these keys you're going to find different, okay? Because I call them soft keys. The first one is personnel within your facility. So this goes out to those IT managers out there. Do you know what kind of relationship do you have with your maintenance manager and facilities manager? Because that's absolutely critical when it comes to repairs, right?
Mm-hmm.
Yeah. So silicone cracks. Some of the root causes that we find are leaks in the ceiling when a storm comes through that shorts out the equipment. because repairs and maintenance aren't being kept up with, I should say.
Mhm.
That's a big deal. The other thing too is airflow line obstructions. When the dirt and the dust from the wind, leaves and things obstruct things, you don't get proper ventilation, which could potentially cause you downtime. My point is if you're not in a relationship with your facilities manager or maintenance manager, those type of things can be missed. Okay, because not everything gets done in that window of time outside of the storm season.
Mhm.
Yeah.
So we're talking about building maintenance
Mhm.
being lax or not being kept up on. There are some examples that come to mind immediately in an access floor type data center. Um, you have, of course, a gap between the actual concrete foundation and where the equipment sits. Um, most sophisticated data centers have water detection sensors in that access floor. Now, here's a not uncommon scenario. The roof in the building hasn't been maintained well, and you've got leaks, and you may not be aware that your access floor is filling up with water because that water is coming down through the walls and eventually migrating out onto the concrete portion of that plenum or that access floor. And if you do have water detection, that will give you an early indication that something's wrong.
Correct.
In the advanced stages, we've seen where water intrusion not only can corrode the electrical circuits underneath the access floor and eventually trip circuit breakers, but if it gets into the equipment, which is also possible coming through the ceiling, for example, now you've got water going in, you've got fans blowing water all around the inside, the electronics, and you end up with a huge problem.
That's correct. And a lot of these issues that Pete's referencing are identified and they're documented. Now, whether or not they get resolved is the greater issue, and that requires follow up. So develop that personal relationship with your maintenance manager, your facility manager. Make sure you know what the R&Ms are and whether or not they're getting done, so you're not surprised.
And then we also, you mentioned airflow,
Yes.
filters being properly replaced. This type of equipment depends on airflow to cool itself. It takes in air and it exhausts it. Now you have to have, filtration and enough AC to handle that heat load. I think some of the worst examples of heat-related failures that we've seen is equipment that is not in the primary data center, but in utility rooms somewhere. And if they don't have heat sensing equipment that will give early warning that there is a heat buildup, then you'll see equipment actually cook itself.
Mm, yeah. Okay. So key number two, that's key number one. Key number two is your power distribution topology. And what they call that is uptime classification. This is what's really scary to me. We serve a lot of different customers, from the attorney that has a UPS in his closet to Samsung that has a megawatt system up against the wall, takes up the whole wall. And what we are finding is most customers that we service don't have basic capacity. Basic capacity is tier number one. And what that is basically a UPS, an AC unit, and a generator.
Mhm.
Most of our customers do not have the generator. Can you
Mhm.
believe? Can you believe that? And that's tier number one. That's the
Mhm.
very first tier. You're not classified if you don't have that basic capacity.
Sure.
Yeah.
Can you hold that thought for a second?
Sure.
It looks like we've got a comment
Pete,
here from
Sorry, you
YouTube.
got to talk into your mic. You're leaning past
Yeah.
your mic.
Okay, YouTube, Chris T. Welcome, Chris. He says, in our shop, we manage and maintain our own UPSs and generators. Our facilities maintenance leaves a lot to be desired and became a liability for IT operations.
Wow.
Well, that reinforces what we're talking about.
Yeah. Great comment. Great comment. So back on this, Pete, basic capacity, there's 4 different tiers. Okay. You've got redundant capacity. We're not going to talk about that today. The third tier is concurrent maintainable. Now your Hurricane Center, Watts Center in Florida, fault tolerant.
Mhm.
Okay. Fault tolerant. That means they have 8 generators, 4 systems. If that system goes down, system 2 kicks on, system 3 kicks on, system 4, because, what would that be if your whole watchtower went out and you had lost visibility to what a hurricane is doing?
Mm.
But back to the original point, I find that very, very scary that, most customers out there aren't even running at basic capacity. So when that UPS, when those batteries run down, guess what? You're down.
Mhm.
You're down. And who knows when you might get back up depending on what the situation is.
And downtime is so costly. And again, I'm going to continue to tell stories here because I got 40 years of history
Yeah.
here. But I can remember even before I started Gruber Power Services. It was in the late 1970s. I worked for Digital Equipment Corporation, which is a mainframe manufacturer. And we had a customer here in Phoenix in a high rise, downtown Phoenix in the Valley National Bank Tower called American Express, which actually grew quite a bit since then. But they had a small PDP 11 16-bit computer in the 26th floor of that high rise. And when it went down, all hell broke loose. They were all over us. We need somebody out here now. We don't have time for you to wait until you get a field engineer freed up. And one day I asked the IT guy, they used to call them data processing managers back then. I said, why is this machine so important to you guys? Because it wasn't very big. A PDP 11 is a 16-bit machine. Today, your cell phone has more power than that computer had.
Right.
And he said, well, this computer is extremely visible in our company because it takes and works the float.
Mm-hmm.
We take money from customers and to process either for their checking accounts or whatever. Well, while that's being processed, we direct these funds into short-term interest-bearing accounts. And when that computer goes down, it costs us hundreds of thousands of dollars
right.
per minute.
Yeah.
So there
Amazing.
you had a prime example of, now, of course, they eventually ended up getting something far more robust than this PDP-11. They got, at that time, there was a company in the computer mainframe industry called Tandem Computers. And they actually started a whole new genre of computing in that you had two computers, two mainframes that were running the same identical program in tandem, and that's where the name came from. So when you had a failure in one, the other one was running and alerted you, one of us is down. You better fix us so that we can continue with a tandem operation.
Interesting. Very interesting.
Which, by the way, also happens in UPSs, does it not?
It does. Pete, one of the things that really, really is downplayed when it comes to back on these keys again is key number 3, and that's exercise. Do you exercise?
Every day.
Why? Why are you exercising?
So that I can safely say I'm 71 and I'm enjoying it.
Yes. And you want to keep moving.
Yeah.
If you stop moving, you get stiff, you get out of shape, and things are more challenging for you to do. It's not any different with UPS equipment. And what we have found is that most of our customers, they're apprehensive, and I understand why, about exercising their equipment, meaning cycling breakers and conductors, cycling the bypass, to wake things up. They don't want to do it because they don't want to risk the load.
Mm-hmm.
Has that
Right.
been some of your experiences too?
It has been, and it's vital. It's vital for preventive measures. Cycling the automatic transfer switch for
Right.
your generator, making sure that you're going to be able. How many times have we been called out? We have a power outage. The UPS isn't bypassed, but we ran out of battery and we realized that our automatic transfer switch did not turn on the generator.
Right.
Either the generator was faulty or the switch was faulty, and you don't know that until you have a disaster.
Yeah, and the thing is, with the generator, it might not necessarily be faulty. It just might be out of sync, because that's something that you do on an annual basis. You always sync the generator with the UPS. So because you only probably have a minute of battery runtime between that syncing.
Right.
You're done. You're a sunken ship if that generator is not in sync. So that's another thing too that should be happening, in terms of a key is if you have a generator, make sure you're following through on an annual basis and, having the generator people come in and make sure that thing is in line with your UPS.
We call it PMs, preventive maintenance.
Right.
And that's, of course, what we do with all of our service contract customers. We come in and we do a preventive maintenance visit.
Yeah. Another story, well, not really a story, but another thing that happened with a down UPS, it went down because this particular location ran out of generator fuel.
Yeah.
Okay. So again, in terms of being proactive and protecting yourself before a storm before storm season comes, you should know what that inventory is.
Yeah.
And if you're light because you had to use it last year, you should be filling up those reserves. I know, and it comes down to money. I hear that a lot. Well, we don't have the money to do it. You know, you're asking me to do a fault tolerant system, but it's millions and millions and millions of dollars. No one's going to approve that, you know, that kind of
Right.
thing.
You know, the only time in my mind that in a critical power system like this, generator UPS combination, that's an acceptable excuse that we don't have any fuel is during a natural disaster when the roads are blocked or flooded or whatever, and the fuel truck can't get to your location.
Hmm.
But make sure that you have a solid relationship with the fuel vendor because, like you said, you know, when that thing is called into action, it's going to be eating some fuel, and you've got to have a supply line.
That's correct. Yes, yes.
It looks like we have another question from Instagram. Welcome, January 9th. He says, hi. Well, welcome, and thanks for joining us. YouTube, EV Fan, is saying, is there a backup for the backup? Well, you know, what we're talking about right now is you have your static UPS, which is inside the building typically in either a utility room or right in the data center with the equipment. And then you have an automatic transfer switch and you have something that's outside, which is typically your engine generator. So that would be the backup to the backup. Now, as we mentioned earlier, in the case of American Express, they had a dual system, a tandem UPS, which actually, I'm sorry, that was computers. That's right. They went to a tandem computer system. In the critical power world, you also have redundancy. The old first generation single phase symmetrics come to mind, for example. If you had N+1,
Right.
you had an extra module in there. So if your primary power module failed, the other one took over
Yeah, even
and alerted you.
even the ones they're coming out with now are basically N+1 for that reason.
Perfect.
Hmm.
So yes, to answer that question, and the follow-up to that question is, if a UPS hits lightning or hurricane, what can you do? Well, some bets are off when you have things like a hurricane. If it, you know, if the roof comes off your building, there's no point in trying to run your data center.
Right.
But you know what this the business we're in is power protection, and what you try to hit is the majority of potential failures. You're not going to catch them all.
You know, there's surge suppressors, lighting arresters out there that kind of block things, but you know, there's no like guarantee that you can.
Yeah.
Yeah.
You mitigate the risk. You can't remove it completely at all times.
Correct. Now, here is probably one of the most important things, battery health management. When you're talking about protection, battery health. So I broke this down into two categories, basically soft maintenance. There is a tremendous amount that you can do just with this thing right here, your senses, when in assessing battery health. Okay, your nose, your eyes. So when I walk into a battery room at a customer site, the first thing I want to sense is what the temperature is.
Okay.
That's extremely important. And of course, the smell. Is there any sort of sulfuric acid or rotten egg smell, even a slight trace of it in the room? Because if there is, you could be on your way to a thermal runaway situation.
You could be boiling a battery that has gone rogue on you out of a string of 40, for example.
Exactly.
Very, yeah.
Yeah. The other thing you can do with your senses, with your eyes, is you can open up the battery cabinet. And again, you don't want to touch anything, especially if it's energized, but you can open up the door and just visually with a flashlight, just look at the terminals to see if there's any corrosion.
Right.
You
Good
know,
point.
and this is all things you can do without the hard maintenance, without any testing. Those things alone right there can tell you whether or not your system is healthy. And I want to throw in humidity, especially during storm season here in Arizona. We get high humidity, and is that a buildup in the room? But the key thing is your AC working?
Mm-hmm.
There have been operations that we've walked into doing site visits where the AC is completely turned off, and you ask the question, well, when was the last time you checked your air conditioning? Well, it was a month ago.
Mm-hmm.
And meanwhile, you know, heat, you know, the spec is 77 plus or minus 5. Your battery room is supposed to be. Meanwhile, this battery room is run for a month and 90 degrees. Guess what? You transfer to battery, you get half your run time, and you wonder why. You know, so those are things that you can do, little tips that you can do with what God gave you through your senses.
I have another story. This one's from Las Vegas, again, about 30, 40 years ago. There was a company up there called Time It, and what they did was ore crushing. Now, back then, computer rooms were fairly consistently temperature and humidity controlled. And the reason you want to control humidity in a data center is to mitigate static. People walking across a floor, especially if you had carpeted access floor, can build up a pretty substantial charge. And when you send a static discharge into a circuit board like this, all hell can break loose because you're redirecting signals, and you're starting to create artificial data, basically corrupting what's going on in that circuit board. So anyway, what they used to recommend in computer rooms was 40% humidity, 72 degrees temperature. So you've got a pretty high humid environment. Well, at TimeIt, they were crushing ore out in the shop areas, and it had some caustic elements. So this dust was migrating into the computer room, combining with the water and depositing on circuit boards. It was so bad that when we went out there at times, the chrome rings around like the keys, to open things up, were actually delaminating. The plating was coming off because it was corroding. Inside the circuit boards, you would oftentimes find green corrosion, which indicates copper oxide. So there's a scenario where, too much or the type of dust that was introduced along with the humidity actually caused reliability issues and reliability problems.
A couple other things that are vital that you can just do, not considered hard maintenance, is know the age of your batteries.
Mm-hmm.
Okay. Review the event log so you can see over the course of time how many times this unit transferred a battery, because every time it does, it eats away at your runtime.
Mm-hmm.
Okay. And if you have a service maintenance plan and you're reviewing and you're getting service reports, proactively review your service reports in terms of the readings that you are getting. Because what you're going to find is there's a trend line. If you plot those out, there's a trend line, and you can also almost predict when your batteries will basically be, due for replacement.
Mm-hmm.
So all those things should be done proactively prior to storm season coming. And I think if you do that and take proactive steps, you can mitigate your chances of going down.
Now, part of what Claude's team does is there are a number of field engineers nationwide that get dispatched to our service contract customers. And when they get on site, of course, it's either preventive maintenance, remedial maintenance, but generally what happens then is there's a service report generated, which goes back to the admin team here or the service team. And from that, oftentimes there are recommendations made, which then get fed back to the customer.
That's correct. And oftentimes in those scenarios, especially when a unit goes down, one of the first questions I'll ask the customer is, did you receive your service reports? And in some cases, or if you received them, did you read them? And in some of the cases, they received them, but they haven't gotten around to reading them yet. And I'm talking months later.
And they haven't acted on the recommendations
That's
in
correct.
that service report.
That's
Yes.
correct. And meanwhile, you get the phone call, well, my runtime is supposed to be 3 hours. I only got 1 hour. Why?
Mm-hmm.
So it gets back to my point on, it's never what it initially is. It's always what it is after you perform due diligence. That's really what the root cause turns out to be. And that's what should be addressed.
It looks like Chris T on YouTube is asking a question again, and he's saying, what are your thoughts on lithium-ion in UPSs, lithium-ion batteries? Okay.
There you go. That's your baby.
It just amazes me. Gruber Motor Company, of course, works on EVs, and we don't have lead-acid batteries electric vehicles. The last lead-acid EV or car that we're aware of was a T0 in 1997.
Well, you've got a small battery in it, right? That's lead acid. That's
Oh, yes.
that's driving. What is it?
I'll get into that.
Okay.
That's a Tesla Roadster battery. Good
Yeah.
point, though. So that was the last car, was a T0. It was the inspiration that actually convinced Martin Eberhard and Mark Tarpenning to start Tesla. They saw the sports car. It would only go 80 miles, though, so they realized that it wasn't quite marketable. How many people want to drive only 80 miles? So it was Martin's idea to take batteries that he was using in his ebooks business, which he just sold, and they used 18650 lithium-ion cells, and he asked AC Propulsion Systems, I'm interested in this electric sports car, but I want you to convert it to lithium ion batteries. So they ended up putting a bunch of lithium ion batteries into this T0, and the mileage came up close to 400 miles versus 80 miles. It became a bit faster. It shaved 0.3 of a second off to 0 to 60. They took it over to Laguna Seca, and a lot of people took notice, especially the Lamborghini, McLaren, and the Ferrari, owners who were running on that track, because this little electric sports car was smoking them all
Hmm.
with a 0 to 60 of 3.8 seconds. So that was the conversion, in my mind, from lead acid battery EVs to the lithium ion multi-cell design. Now, fast forwarding a bit here, I can't answer the question why the critical power industry is not wholeheartedly adopting and embracing lithium ion batteries.
You know what? I think it's the safety aspect. You see these videos of,
Yeah. Well, he points that out. He says critical environments, given their potential volatility, fire risk, and thermal runaway, he says lead acid fails, it just stinks, whereas lithium ion fails and it's a problem.
Mhm.
And I think you're correctly identifying the stigma and the reservations of switching critical power equipment over to lithium ion. Now, let's put this back in perspective. In the early days, when we first got started in the early 80s, I took a service contract at Revlon, the Revlon warehouse we're talking
Mhm.
about. It was a 75 kVA X-side UPS that was in a special room with lead acid batteries, the big 2-volt wet cells that weighed 125 pounds, and they were 2 volts apiece. So you had to hook a whole bunch of them in series to get even 120 volts, Um, in fact, that'd be 100 of them, wouldn't it? At 2 volts, 120 volts, right? Yeah, it just occurred to me. That's why this room was so
Oh,
big.
exactly.
But in that scenario, you also had a fire risk because these things were gassing, they were venting, and it was hydrogen gas, which is of course highly
Health
explosive.
risk.
Yeah. So, but then of course, absorbent glass mat technology came along, which was the next generation gel cell battery, maintenance free, completely sealed, and that's where UPSs have been stuck now for decades, is in lead acid AGM batteries. Now, fast forwarding a bit, the newer lithium ion cells that are coming out now, like the ferro LFP cells, they don't have the fire risk like the lithium ion do. So the excuse is gone now. If you're listening out there, critical power vendors, you can switch to a far better technology, much more energy dense, by going to the newer type of cells.
So Pete, how did they mitigate the fire hazard? What did they change it technically to do that?
A lot of air exchange, fans, venting. In fact, the city would often get involved with permitting issues to make sure that they, were properly exhausting
Mm.
those volatile gases. And I'm sure there were environmental concerns as well.
Right. And being able to handle this, just battery is zapped. What do you do with it then?
With this wet cell,
Yeah,
um,
no, with the lithium ion, back on his point here, just what do you do when the battery's zapped?
oh, okay. Well, this is another reason to switch over to lithium ion or lithium iron phosphate, LFP. The lifespan of these batteries is infinitely longer than the current AGM lead acid type cells. Now, wet cells, granted, are good for 20 years or so. But again, nobody wants to use those anymore because of the hydrogen gassing, the special room you have to create, and the risks. But the bread and butter of the UPS industry DC storage is still AGM, lead acid batteries, which how long do they last?
3, 4 years.
3, 4 years,
Mhm.
exactly. The best example of a lifespan expectation for lithium ion multi-cell batteries in EVs is the Tesla Roadster. It was really the first car and the first application for multi-cell 18650 cells. Everyone thought they were going to last 10 years. J.B. Strobel, I spoke to him a couple of years ago, and he says, we're all pleasantly surprised that these batteries, and he has 2 Roadsters, are lasting more than 10 years. That was our design life. Now they're going on 15 years.
Okay, now the design life based on what? Is it like how many miles are you getting out of these?
It's difficult to create a finite measurement for
Mhm.
things like that,
But
design life, for
but an
example.
average, what do you think?
Well, we still don't know
Mm.
because the Roadster is going on 15 years and they still have 18650 cells in them. Now we know that there's going to be an end of life type experience for those cells. The closest we've gotten to that was a defective batch of cells that was released in 2016 by Tesla. That now, 7 or 8 years later, it is starting to manifest impedance problems, lack of power. The same thing that we saw years ago when we had a bad batch of batteries that came from China.
Mm.
But no one knows yet. But the UPS world can definitely transition to the newer lithium style batteries and quite safely, actually. So, your earlier question, isn't there a 12-volt
Yeah.
DC battery in a Tesla Roadster? There wasn't in the first series. There were 500 of them built. They're 1.5 Roadsters. And Tesla realized that they were grabbing 12 volts off the 400-volt battery by taking a voltage from one of the sheets. And because there's such a high demand for 12 volts in any car, locks, headlights, audio system, switching, even the electronics, it was really beating that sheet up, one of those sheets, to the point where there were premature failures. So they made a design change after VIN 500 on a Tesla Roadster, and they tried to fit a 12-volt battery in there somewhere to run the 12-volt devices in the car.
Mm-hmm.
And then a DC to DC converter that would charge from 400 volts down to 12 volts to keep this battery alive. It was an afterthought in many ways. They parked it underneath the headlight on the passenger side inside the fender. So in order to change that battery, and
Yeah.
the AGM batteries have to get changed every 3 to 5 years. You had to take it to a service center because the average individual didn't want to dig into the car and do that themselves. And it was a motorcycle battery, like a 9BX7 or something, which is about an 8 amp hour battery. So yes, in the even later Teslas or the EVs, they had to insert a 12-volt battery in order to power all the 12-volt devices. And now Tesla has finally begun to change that by creating a 48-volt bus for the low voltage devices in a car. The fundamental reason they didn't want to run off the main battery in an EV is if you had 400 volts DC running to your headlights and audio system, you'd probably be killing technicians because those are lethal voltages. And you certainly didn't want to run the appropriate cable to those, which is thick orange cables, fully protected, because again, the cost would be prohibitive. So they maintained a low voltage and a high voltage battery system in EVs.
Interesting. Okay, well, back on the hard maintenance, taking care of your VRLA batteries in a UPS system, the other thing is torque. The torque specs. One thing to look for if you have received a service report, you're getting them on a continuous basis every 6 months, is see if there's any note in there about torquing the batteries. If there's not, that's kind of a red flag because that's very important because if you're not doing that, what does that drive? Loose connections.
Now, are we talking about checking the torque specifications on the batteries? Okay.
Yes, checking the
Gotcha.
torque specifications. Of course, on an install, you're going to do that anyway. That's part of that protocol process is to make sure the batteries are properly torqued. But over the course of time, you have to look at these things from a hard maintenance standpoint.
And it's the same thing with circuit breaker panels. One of the things that they use quite commonly now is they use infrared cameras to look for hot spots inside a circuit breaker panel. Inside a breaker panel, you have a number of circuits that are being fed to various parts of the building, and they couple to a circuit breaker, which is just a screw-type compression fitting, onto the copper wire. Well, as those come loose, and I'm not saying if they come loose, they do come loose, you start to build up heat. Copper is a soft metal. It eventually relaxes with that compression. So it's a good idea to have the electricians periodically go through and check your breaker panels. And the same is true with the UPS battery connections inside the battery cabinet.
And the UPS components itself. Because what that's going to save you, if you can identify that hot spot, that's going to save you return trips versus sitting there going out 2, 3, 4, 5 times, shotgunning parts. You can see where it's hot, bring that one part, and eliminate all those trips. At least that's how it's been working for us since we implemented those cameras about 3 years ago.
And part of our preventive maintenance procedure, and this is the other reason to get regular preventive maintenance on your critical power equipment, is to torque all of those connections on the batteries or check the torque. Looks like we have another question coming in. Chris T again from YouTube says, we replace our SLA batteries about every 3 years or so. So the lithium-ion batteries have been a tempting option for us, and we're testing lithium in some 48-volt UPSs, but don't see any viable retrofits for the larger UPSs or the 120 to 192-volt strings. Yeah, there are some manufacturers that are beginning to put lithium-ion type batteries or lithium iron phosphate batteries into smaller UPSs. They're kind of getting their feet wet, but not quite committing to doing the large UPSs yet.
Well, Pete, what do you have there on APC?
APC, all right. I thought we would go through a little bit of history on each of the UPS manufacturers during these sessions because there's an interesting story to tell there. The first one is that UPSs have not been around forever. I remember in the 70s and 80s, UPSs were extremely expensive. We're talking about hundreds of thousands of dollars for even a 75 kVA UPS. That one at Revlon is a prime example of that. So the first level of power conditioning for critical power tended to be transformer-based power conditioners. Tap switchers were very common, and what a tap switching power conditioner is, it will automatically adjust taps on the transformer by using SCRs to regulate the power, so the output side remains constant even though the input is varying. Another parameter in a good power conditioner was the isolation ability, and a triple power conditioner or triple isolation power conditioner was one of the best. It had like minus 120 dB noise rejection, and that was primarily to take care of spikes and transients. What those are very short duration spikes in voltage that migrate through into the equipment eventually and cause all kinds of problems inside the circuit boards where you have very small voltage signals. And typically what causes spikes and transients is heavy load switching. If you're in a commercial building, you can't guarantee what the rest of the neighbors or your neighbors are going to be doing. There could be welding taking place. There could be elevators running up and down with heavy arcing type load switching. All of that sends nasty spikes down the power line. And so these power conditioners would typically regulate. They would provide a degree of isolation from the problems down on the grid or in the power line. At some point in time, a third component became important, which is now called ride-through. And that's the ability to continue to provide power if a power outage occurs. And that's where UPSs really took over. For a brief time, they used ferroresonant transformers for power conditioning. And what those would do is they didn't have tap switchers. There were no semiconductor devices. It was a special wound transformer that had a parasitic winding that actually allowed some ride-through, up to a quarter cycle ride-through. Now, it doesn't sound like much. We're talking about one sine wave is 1/60th of a second. This power conditioner, ferroresonant power conditioner, was able to ride through 1/4 of that sine wave.
Right. And how old was this technology?
It was prevalent during the 70s, 1970s, 1980s, until UPSs began to really take over. And now you got the benefit of having ride-through time or battery time, and a double conversion UPS took care of all of the noise that was coming down the line, because essentially the only thing utility power was doing was charging your batteries in your UPS. The actual AC, the three-phase AC that was being generated by the APS, was being done within the UPS, and there was no power coming from the utility other than to charge the batteries.
No, that's a great point you make, and I missed that. It was the whole charging operation within the UPS and how it's important to make sure that you're not overcharging your batteries and checking to see if you're charging your batteries at all.
Right. Yep. Good point. So that's kind of the migration of UPSs, and then some companies began to emerge. APC, which stands for American Power Conversion, was actually founded by three MIT lab type engineers. And their first focus was to provide product or to do solar research and then eventually provide product for the solar industry. And back then, there was a lot of federal grant money available for this sort of thing. And like most universities, they depend on that. So by 1981, they began to focus. I'm sorry, 1984, they began to switch over to creating some UPS type product, uninterruptible power system product. But it wasn't the mainstay. They were still thinking they were going to be a solar company at that point in time. And I've got some timelines here that are kind of interesting that will give us some dates. So in 1981, the three engineers at MIT working on solar. By 1984, they began to transition into power protection or UPSs. By 1989, they introduced their PowerShoot software. Do you remember that? I think it's still in use, actually.
It is.
And, being engineers, they were interested in both software and hardware. Back then, the other guys, Exide and Lieber, they weren't focused on software. They were still making tons of hardware, big UPSs. By 1990, APC developed their most popular UPS line called the SmartUps. Do you remember that?
Oh, yeah.
And in fact, the acronym SU2000 is SmartUps, 2000 VA or 2000 watt, which really began to take them much further. Somewhere along the line, a guy by the name of Roger O'Dowell came into the company and began to legitimize the company in many new directions and new ways. By 1999, they briefly entered the residential market with the Power Shield solutions for home applications, and by 2002, they developed a integrated product line called the Infrastructure. Now, it's not spelled the way it sounds, but I think they intentionally did that to avoid some infringement issues. But this infrastructure line took them into the large UPS business now, 250, 500 kVA, and even larger. And by 2003, they began to combine into this infrastructure cooling. In a data center, you have a number of components: access floor cooling. It used to be halon for fire protection, and of course, clean power conditioners then to UPSs. But so they felt that they were able to combine the cooling portion with the UPS, and they integrated this into their product line. And today, many data centers are still using APC cooling systems.
Yeah. The other thing to add to that too is just the infusion of the modular unit back then. I mean,
Scalability.
we still service PXs, APC PX modular unit that was, manufactured in 2003. These UPSs are still running. They're hot swappable, and they work well.
And the advantage of what Claude is talking about, and this was an APC innovation as well, was the scalability aspect. It used to be that when you had a UPS application and you needed 75 kVA or 125 kVA, you bought a UPS, and typically the sales rep would advise you, do you have any growth plans? You might want to go 150 instead of 125. The problem then occurred is when you hit 150, because you didn't properly forecast your growth, you had to buy a whole new box.
That's correct.
A whole new system. What this scalability program that APC developed allowed you to do was to buy a 125 kVA UPS in a 500 kVA capability, and then through modules grow. And it was either 10 kVA with a single-phase Symetra, to up to, how large did that go, the single-phase Symetra? 16 kVA, right, 4 kVA modules,
right.
4 of them,
right.
with some redundancy built in with an N+1. In the 3-phase world now, they went up to 500 kVA.
Right. You're starting at 20 there, all the way up to 500 kVA.
Okay.
Yeah.
In 25 kVA modules?
No, they're 10 and 25.
10 and 25 kVA growth.
Yes.
okay, modules. And the other cool part was these were hot swappable.
Yeah.
Now that was quite an innovation. What that means is your equipment's running, you've got all of your stuff connected to it, your whole building is running off this UPS, and you decide, I want to add another power module to give me some more
Right.
capacity.
And that gets back to your topology that I was talking about earlier. That's where you get out of basic capacity to concurrent maintainable capacity, because now you're in the N plus one, N
Mhm.
plus two. You have that backup capability, that redundancy.
Right. And if you needed more batteries, they were also hot swappable.
Yeah.
You could take battery modules, which, by the way, we refurbish here and we
Yeah.
rebuild.
That's a huge game changer.
Mhm.
On the component UPS side, where you have an individual battery cabinet with 40 batteries all in one string, one of those batteries goes bad, your string is toast.
Mhm.
Okay, you have no runtime. You can't
Right.
run. In a scalable modular situation, if one of those modules goes bad, you can just pull it out and the other ones still support the critical load.
Right. So you're operating at some limited capacity,
Exactly.
but still with the if you've planned your growth correctly,
Right.
you'd never even notice it then. So that was another APC innovation, combining both cooling, scalable UPSs, and the other thing is financials. I've got some numbers here. So by 2000, oh my God, I don't have the date here. They hit $1 billion in the last century combined revenue. And then this CEO, Roger O'Dowell, decided to start opening factories all over the world. It's kind of what Elon's been doing. We heard just recently that there's yet another gigafactory going to be built in Monterrey, Mexico. And then we heard that they're looking at India now. He's talking to them about another gigafactory there. And just this week, we heard that Spain there's some discussion about creating a gigafactory in Spain. Well, apparently Roger did the same thing with APC. And what that does is there are a number of advantages. You don't have to ship your product all over the world. You can capture business in the markets right where your plant is. It improves the supply chain tremendously. So let's just run through the topology here then for a moment. 1981 founded. 1982, they begin manufacturing lead batteries. We didn't talk about that. By 1984, they abandoned the solar business and they introduced their first uninterruptible power supply product, which was the 750 VA
Smallest one.
UPS.
Mhm.
They didn't have smart ups yet. By 1988, they complete their IPO and they went public. By 1994, they established their first overseas facility in Galway, Ireland. And if you Google this, you'll see that from there, they created factories all over the world, typically about $20 to $30 million in terms of size.
Yeah, Pete, and just to put that in perspective, when you mentioned the 750,
Mhm.
okay, that particular UPS, that is a plug and play UPS that basically supports your computer.
Right.
Yeah.
And we didn't mention this, but part of the reason that their product took off and that there was such great demand during the 1970s, late 70s, and early 80s, there was a big migration in the computer world from large mainframes that filled entire data centers to distributed processing. In other words, power at the desktop.
hmm
And all of those needed clean power right along with those large UPSs in the data centers. And APC was right there with small SmartUps UPSs that you could put underneath your desktop to keep the power
Correct.
clean for your computer. And then, of course, you have, fast food. You've got point of sale equipment. Every single one of those gets a UPS. I remember one of the big contracts that Best Power Technology got was the McDonald's contract for, a UPS on every point of sale. And we're talking about multiple cash registers in these fast food places. It
Right.
wasn't just one.
What a
you know?
mess, huh?
Oh my God, yeah. And you know what? At that time, we were their number 2 reseller. And the only reason we were number 2 was because the company that had the McDonald's contract was number 1. So anyway, 1998, then APC acquired a company in Denmark called Silicon AS. And now their sales eclipsed $1 billion. Silicon was the same company that Best Power Technology used for 3-phase UPSs, and they built a really stellar highly advanced three-phase UPS.
Silicon
Yeah,
or silicon?
silicon.
Silicon.
It became the APC Silicon UPS,
Okay.
and Best called it, you're going to have to help me here. They had the same brand rebranded under their name. It escapes me now.
Oh, the Ferris?
No, it was not the Ferris. It was their first entry into the three-phase world. It'll come to us.
Okay.
We'll probably hit it in the next show here. And then by 2003, sales approached 1.5 billion. Anybody want to guess where they're at today in terms of gross revenue?
Anyone?
$3.5 billion. American Power Conversion, called APC. So our goal in these podcasts is to educate, enlighten, answer questions, and we have plenty of other manufacturers that we can talk about, and some interesting stories. You know, one of the early stories that I have for you with the original APC design engineers, and remember, our company got started in 1983, which was around the same time that APC was getting going. And I remember talking to one of the original MIT guys, and he said, you know, we were so small at one point in time that we used to take circuit boards home with us at night and put them into our kitchen oven and bake them all night long. And I forget why they were doing this. It had something to do with setting epoxy or something on the circuit boards. So
Wow.
look where they are today, you know. All right. Do we have anything else that we want to cover in this
That's
podcast?
1 hour and 3 minutes, just so you know.
Yeah, just one thing I wanted to say. This is like a lot of fun, and we want to learn from each other. You know, by no means do we know it all. So anything, observations that you guys, notes that you want to chime in, questions that you want to ask, we encourage you to do so.
And we ask you to contribute as well. You know, some of you may be IT managers, and it looks like one of them that's been asking questions may be, or a user. Field engineers, people that are in the industry. Many times, you know, we look to you to answer some of these questions or share your experiences as well. But the goal of this is to edify, educate, and entertain, and you know, be a mover in this space.
So go Cheetah.
What are you talking about?
The cheetah at the very beginning of this podcast. That is what we're striving
Oh, your
for.
picture.
That's
Yes,
right.
yes. The aerodynamic cheetah.
That's right.
75 miles an hour.
Yes.
That's amazing. Well, we appreciate you joining us, and we do these every Friday now at 10 a.m. Pacific Standard Time until daylight savings. Then we'll call it MST again, Mountain Standard Time. And again, if you have any questions during the week, would you like them to email them to a particular email address?
Yes. You can email me at D as in dog, I, X as in X-ray at Gruber.com.
Okay. And we have one more question. YouTube, Chris T., thank you for joining us again. He says, great podcast, guys. I'll keep an eye out for future ones from y'all. Thank you for joining us. We'll see you next week.
See you next week. Thank you, sir.